Hey, student, how are you? Welcome to our session on finding the domain of functions. We're going to take a look at these 11 problems. All right. And the domain. The domain is the x values, the input values that result in real number outputs. So we don't want to take the square root of a negative number. You'll get an imaginary number, and we can't divide by 0. Linear, quadratic, polynomial, and cubic functions are all continuous functions with no domain issues. So their domain is all real numbers. Negative infinity to positive infinity. No domain issues. We do have to look out for square root functions or even root functions. We don't want to take an even root of a negative number. So we need to make sure that whatever's under a radical, an even root, needs to be greater than or equal to 0. And then a rational function, we can't divide by 0. So no 0 in the denominator of a fraction. If we substitute an x value that results in 0 in the denominator, we need to exclude it from our domain. All right, let's take a look. Number 1, we have a linear function. A linear function is continuous. There are no domain issues. So our domain is all real numbers. We're not taking the square root of a negative, and we're not dividing by 0. There is no denominator. Number 2, a quadratic. This is also not going to have any domain issues. We're not taking the square root of anything, and there is no denominator. So our domain, once again, will be all real numbers, negative infinity to positive infinity. Number 3, polynomial. Polynomial function. Nomial function is also a continuous function with no domain issues. We're not taking the square root of a negative. There is no square root. And we're not dividing by 0. Speaking of dividing by 0, numbers 4, 5, and 6 do have denominators. Number 4. We can't divide by 0, so we need to exclude any x value that makes the denominator 0. So we'll set the denominator, x minus 3 equal to 0, and solve. And we see the denominator is equal to 0 when x is equal to 3. So we need to exclude x equals 3. So all real numbers except 3. We'll write it in set notation, negative infinity up to 3, but not including 3. So we'll use parentheses. Union, we'll jump right over 3, and we'll go to positive infinity. Number 5. We'll set the quadratic in the denominator equal to 0 and solve. Let's factor. What two numbers multiply to 10 and add to 7? 2 and 5. And we'll set each factor equal to 0 and solve. And we see that we need to exclude when x is equal to negative 2, and when x is equal to negative 5, we will get 0 in the denominator. So our domain, negative infinity up to negative 5, but not including negative 5. We'll jump over negative 5, we'll go from negative 5 to negative 2. Union, we'll jump over negative 2 and go right on to infinity. There's our domain for number 5. Number 6, the denominator cannot equal 0. Oh, and this denominator will never equal 0. X squared will never equal negative 4, so there are no domain issues. Negative infinity to infinity is our domain, all real numbers. Moving on. Let's take a look at some square roots. So when you're taking the square root, you don't want to take the square root of a negative number. So let's see, when is x plus 9 greater than or equal to 0? And we'll subtract 9, and we see that x is greater than or equal to -9. So all the numbers greater than or equal to -9. So our domain, including -9 up to infinity. All numbers greater than or equal to -9. Anything less than -9, and we'll get a negative under the square root. We don't want to take the square root of a negative. Number 8. Let's solve this quadratic by setting it equal to 0, and we'll factor. What two numbers multiply to give us -12, add to -4. Multiply to -12. -6 and +2. And we'll solve by setting each factor equal to 0. And we get x is 6 and x equals -2. And then let's set up a number line and see when do these values when is the quadratic greater than 0, positive? We can include 6. I'll put a closed circle. We can include -2. We can take the square root of 0. That's okay. And then I'm going to substitute -3 into our quadratic and make sure that we do get a positive answer. So that means everything less than -2 will result in a positive number under the square root. And we do get a +9. So all numbers less than -2, including -2, will result in a positive or a 0 under the square root. And then let's substitute 7. We'll see if we get positive solutions. And if that doesn't work, we'll check in between. We do get +9 once again. So everything greater than 6, including 6, will be included in our domain. Everything in between here will result in a negative under the square root. So our domain is everything less than -2, including -2. Union will include 6 with a closed bracket and go to positive infinity. And number 9, we can't have 0 in the denominator. We want to make sure that we're taking the square root of positive numbers greater than 0. So we'll set x minus 2 greater than 0 and solve. And our domain is all numbers greater than 2. So we cannot include 2. That'll give us 0. So 2 to positive infinity is our domain. And the last two. Number 10. I see in the top we've got a square root, so we need to make sure that x minus 3 is greater than or equal to 0. So when x is greater than or equal to +3, the numerator we can evaluate. How about the denominator? The denominator cannot equal 0. So let's find when the denominator is equal to 0. -49 is equal to 0. And we could factor a difference of squares and then set each factor equal to 0. Either way, we get -7 and +7. So this is when the denominator is equal to 0. So we need to exclude these values. However, we don't even need to worry about -7 because x is already greater than or equal to 3. So we need all values greater than or equal to 3. So we can include 3, and we'll go up to 7, but we need to jump over 7. We cannot include 7, and there is our domain. And the last one. Our numerator, x plus 6, needs to be greater than or equal to 0. We don't want to take square roots of negative numbers. So x has to be greater than or equal to -6. And then the denominator. Let's solve x squared minus 25 equals 0. We cannot have 0 in the denominator. And then we'll test some of our values. Let's see, x squared is equal to 25. Oh, and then we can take the square root. Take the square root. And we get plus or minus 5. X equals 5 or negative 5. And then we can test these values. 6. There we are. Did I get them all? Yep, I think I went further enough there. So already we need x is greater than or equal to negative 6. And we can include negative 6. And then we'll go up to negative 5, but we have to exclude negative 5. And then if we substitute any values in between negative 5 all the way up to positive 5, this is going to result in a negative under the square root. And then we have an open circle on 5. We cannot include 5. Open circle on 5. We cannot include 5. And then greater than 5. So everything from negative 6 up to negative 5, but not including negative 5. And we'll write this in set notation. Bracket include negative 6 up to negative 5, but not including. We'll jump over negative 5, and we'll go all the way up to positive 5, but not including to infinity. And that concludes finding the domain of functions. Thanks so much for joining this session, and I'll see you next time.